You guys had the opportunity to complete a homework. How did it go? Any questions on it? Seemed like the hardest thing was turning it in. All right, so I think one of the things that you guys had trouble with is like, how do you get it out? I think you can just drag it out onto your desktop and it'll make a copy for you. And then, did anybody try and upload it more than once? Did it work?
The wrong one once.
Did it work when you re-uploaded it? Okay, because that was an issue with Blackboard last year. So. If I didn't explicitly say like allow re-upload or multiple times, then people would freak out and upload the wrong one. So was it like on a scale of 1 to 10? Was it 1 being like really easy, 10 being really hard? Where do we think it was?
This was the copy.
Yeah. Like a 5, a 2, 3, 2, 2, right? So not real hard for most of us. Okay. So part of the goal was to at least get you into that mode of, well, this is the kind of things that we're going to start doing, right? We're going to get into more complicated things, right? They're not super complicated, but we've talked about what happens if some event occurs or some condition exists. How do we decide we're going to do something different, right? If I'm going to walk to class and I haven't taken a shower, then I might take a shower, right? If I didn't take one the previous night. Or if my user types in a bunch of letters and I ask them for a number, right, then what do I do, right? How do I take that into account? Right, so we'll get into doing some of those options. So second thing, since you guys said it wasn't super hard, right, is how is the group project going? Do we have a algorithm sketched? I got a smile. I don't know if that's a good one or a bad one.
It's definitely a lot harder than the other.
A lot harder than the other one. Well, that's what you have group members, right? So hopefully, right? Hopefully it involves a little bit of research, right? Yes? No? Yeah? You're understanding like how matter works? That's always a good thing. How do you melt things? Or how do you put energy into them? How do you read like super complicated tables? So I didn't send you guys this. I have to look at it even more. But see, it's in here. So I asked a chemistry professor. Let me see, is this the one? Okay, no, there's another one here. I'm like, hey, do you have like something you can give me? And he gave me a sheet that looks like this. I'm like, holy cow! There are a lot of numbers on that page. Even I look at it and go, well, maybe I can figure it out if I remember my periodic. And he says, oh, I just did some simple Googling. I'm like, well, I don't know how simple that was because there's a bunch of letters in there. I have no idea what that T means, unless that's like temperature. And there's some alphas and betas. And so I'm going to hopefully get a more simplistic number out of him or a set of numbers, right? Because you need, how many numbers do we need? 6. If we're going to vaporize, right, we need the how much energy do you have to put into warm it when it's solid? How much do you need to phase change? How much do you need to warm it when it's liquid? Another phase change, right? And then if you're heating it beyond that, right, then you got another number, right? Do I got all the numbers right? Sure, you guys watched the video a couple times? To figure out what he said, what the numbers were he put in, pause it so you can write down the math, see if you can find numbers that look like that. So, what you should think of is I am the person who's going to use your program. I basically, to some of the teams I said there's kind of two different choices you can make. So I want you to be able to do the following things. I need to check and see if your math is right. Right, so given a certain set of inputs that he provided for lead, right, do you get the, 9,000 joules, I think, was the final number. Right, so do you do the math right? So you need to be able to show me that you can do the math right. And then do it for either steel, or if you want to do it for just iron or some other non-alloy, right? So steel is like a mixture of carbon and iron, I think. Is that it? Is there anything else? What? Not sure. It's a mixture of at least two things. All right, so it has a different set of properties, right? Because it's a compound, not just a single solid. So again, if you wanted to do that for something else, right? If you wanted to pick, right? Iron is Fe, right? I think it's copper, Cu, right? So yeah, you can look those up. But then do it for another set of inputs, right? And the thing that I would like to be able to vary at the minimum is what is the mass of the thing that I'm warming up, right? And that's going to change your number, right? So a bullet is going to take less energy to melt, right, than let's see, what's something else that's made out of lead? An anvil made out of lead, right? That would take more energy to heat up the anvil than to heat up the bullet, right? So I should be able to vary at least that. Now I had some groups had said you were going to let them enter all of the numbers, and that's fine. So enter, what is the amount of heat needed to heat up a solid for this thing, right? A liquid, a gas, what is the phase change amount, right, for each of the two? That's perfectly acceptable as long as you have those numbers, right, as part of your documentation. Okay, so are there any questions on what we're supposed to be doing or what we're designing at this point? You can ask anything. I'm unclear on any requirements. Okay, so what I'd like by Friday is for you guys to turn in what is your algorithm going to be, right? So in an algorithm form, I don't want code, right? So either written out on paper and then scanned in is fine, or you can take your camera, right, and take a picture of it. That's okay, right? Or right, you can type it out, or you can go and use Visio or OmniGraffle or whatever software you want to draw it. Draw.io, I think, is another one. So I want at least an algorithm sketched out. You'll turn that in on Friday. And then today, hopefully, right, we should have some time here where you guys can go and, if you've got the algorithm already sketched out in your head, right, you guys can go to the lab as a group and start programming today. Right, so I think the program will be due on Monday, right? So you'll have to have a solution for that by Monday, right? So I won't make you have it on Friday, right? We'll have a lecture on Friday and questions on Friday. So any questions on any of that? And I'm going to try and make a Dropbox that lets you do stuff as groups, but I don't know how all of this will work. This is my first time on Canvas. I think I can make that work. So, any questions? If anybody doesn't have a group, anybody not have a group? We got a couple people, so I think we had what, 6 groups? 7? 8 groups. So, how many people were in group 5? 1, 2. Were you in 5? Who's in 5?
Yeah, I was.
How many people were in your group? Were there 4?
I think there were 4.
What about group 6? How many people were in your group?
4.
Okay, so I think group 7 and group 8.
Group 7 have 3.
Group 7 has 3, so one of you two can go with group 7, the other one can go with group 8. Okay? And you can ask them what we're doing if you missed class, right? So They'll show you the video that is totally awesome, and you can watch it and understand its funness. Okay? So go ahead, and if you got an algorithm, right, head to the lab, start coding. If you don't, finish that algorithm. You need to turn it in on Friday.